NuSpace is going to build an affordable IoT platform by using their nanosatellite constellations technology. Now here's Johnny.
Thank you. 16 December 2015. NUS launched its first nanosatellite, Galatia. Within the first hour of the launch, we received Galatia's first beacon signal, telling us that it was alive and healthy. Galatia went on to complete a very successful mission, generating a lot of scientific research data. That is how NuSpace began. Ladies and gentlemen, a very good morning to you. My name is Zhen Ning, CEO of NuSpace, and together with my team, we're offering an affordable IoT platform using a constellation of nanosatellites. We have a problem. Today, in this digital age, 85% of the world is still not connected. As a result, IoT technology cannot be implemented in these areas. The IoT industry is expected to boom. For example, 70 million devices for the asset tracking industry and 75 million devices for the agriculture industry. These two industries have one thing in common. They require devices to be located in areas where there's limited to non-existent communication infrastructure. There are existing solutions in the market, but they are not optimal. Existing solutions use large satellites, the size of buses, to relay IoT data. These satellites cost more than $100 million each to build and deploy, and they are optimized for high data rate applications, not IoT. As a result, it becomes very expensive to relay IoT data over these satellite networks. It costs an average of 60 cents per IoT data transmission, and this is definitely not scalable, especially when you're talking about large data sets for data analytics application. Our solution is to deploy a constellation of nanosatellites, the size of shoe boxes. These nanosatellites are relatively cheaper to build and deploy, and they are optimized for IoT. As a result, we are able to offer IoT connectivity service at 1/10 of the market rate. That is our goal. How do we get there? We'll take gradual steps. The Galatia project allowed us to develop our technological capabilities. Today, our team is able to design and build our own subsystems, such as the payload computer and the attitude determination and control system. We are then able to integrate this into a nanosatellite, and these nanosatellites are able to be configured for various applications, such as aviation and maritime monitoring, imaging, and communication. So how do we go commercial? We'll start off by offering satellite engineering services, as well as taking one-off satellite build projects. These satellite build projects, although their main purpose is not for IoT, but we'll work with our customers to allow us to put our IoT payload in their satellites. Once one of these satellites go up into space, we'll be able to start offering basic IoT connectivity service. The initial connectivity service will be able to serve applications that are not time critical, such as weather monitoring, water quality monitoring, and agriculture monitoring. With our satellites up there demonstrating our capabilities, we'll then move on to raise funds for us to expand this constellation. With 14 satellites up there, we'll be able to serve semi-time critical missions, such as asset tracking and livestock monitoring. And with 35 up there, we'll be able to serve time critical applications, such as tsunami warning systems and forest fire monitoring. Our competitors can be split into two main categories. The first category are the conventional satellite operators, who are cost ineffective when it comes to IoT application. The second group are nanosatellite industry players who are cost effective, but their emphasis is not on serving the Asian market. The first key differentiator is between us and our close competitors is the way we implement IoT. Today, there are two common ways of implementing IoT connectivity, and there are pros and cons of each way. In order for us to have the best of both worlds, we'll be combining both implementations into one, and this will be achieved with our Space IoT protocol. The second key differentiator, to our best knowledge, is that none of our competitors actually have in-house satellite building capabilities. Having in-house satellite building capabilities gives us the flexibility for us to adapt quickly to the ever-changing needs of our customers. It also gives us better control of the engineering trade-offs in order for us to build a satellite that's optimized and high-performant. A bit of ourselves, Dr. Losha, she's the advisor and co-founder of NuSpace. She's also the project investigator for Galatia. Myself, who's the CEO and co-founder, and Johannes, who's the mechanical lead in our team. Galatia was designed for a 1-year lifespan. but to today, it is still operational. That's 3 years already. And because of Galatia, we actually won ASEAN Outstanding Engineering Achievement Award. This is truly a testament of our engineering capabilities. Together with us, we have a strong pool of advisors. Professor Loh Kay Soon, who's a director at Satellite Technology and Research Center, he'll be advising us on the engineering aspects of the company. Mr. Clarence Tan, who's the founder of Origin, he'll be advising us on the business and investment strategy. And Mr. Jonathan Hang, who's the president of Singapore Space and Technology Association, he'll be providing us with the industry networks and connections. These are our stakeholders and partners. In particular, I'd like to highlight Add Value Technologies. They are a listed company who has strong expertise in RF technology, and they are also very experienced in satellite communication. We're really fortunate to have their support. This is our 3-year financial forecast. In our second year, we expect to be making a profit from the satellite engineering services as well as the one-off satellite builds. And with our satellites up there demonstrating our capabilities, in our third year, our valuation of the company would go up. And that will be the time where we will raise funds for us to expand the constellation. This is a longer forecast, and as you can see, the cost increases significantly whenever we are trying to deploy the constellation, but it comes back down once we're done with it. But in the 7th year, 2025, it starts to go back up again. This is because we'll be launching satellites again at that point in time for us to maintain as well as upgrade the constellation with more functions. Today, NuSpace is raising our seed round, and we are in a very advanced stage of securing a portion of it. This investment will be used to fund manpower for us to start offering satellite engineering services, and once our IoT payload is up there, we'll be able to start offering IoT connectivity service to bring in early revenue. So if you're keen to invest or partner with us, do look for us outside at our booth. And with that, ladies and gentlemen, I'd like to thank you for your time and your kind attention.
Thank you very much, Zhening, and welcome back to the Earth. Okay, now we open the floor to questions.
Just give us some idea. How much does it cost to build this nano satellite and to launch it to space?
Okay, so to launch into space, we actually have to use commercial rockets. At the moment, it actually costs about 300 to 350,000 US dollars for us to launch a satellite that's about 10 by 10 by 30 cm. But we expect this cost to go down because there are more and more companies offering dedicated launch services for nanosatellites. So this price is expected to go down. As for the cost of building a satellite itself, because we have control of designing and building everything and doing everything in-house, we're able to bring the cost of building this satellite down to maybe about 200, 300,000 each.
I saw your projection is, in the next 5 to 10 years, but your lifespan of satellite is only 1 year, although it's still surviving now 3 years. But if you take too long to develop, by the time you really have a network satellite, your early batch of satellite already died. Then your 200, 3,000, hundreds of thousands are wasted. How are you going to solve that problem?
Okay, that's a good question. So the first satellite that we launched, it was designed for 1 year. But the subsequent satellites that we're launching, they are designed for a longer lifespan. So that would already answer the question that because it's 1 year. Because instead of 1 year, we'll be designing it for 3 to 5 years of lifespan, which is why we only start to replace the satellites in 2025.
Thank you. For such a small box, how do you manage the end of life for the product? I mean, typically it should crash down to Earth, or you have a collection mechanism?
Okay, in the recent years, because there are more and more people launching stuff into space, the space is actually getting more and more cluttered. So there are actually talks about how we can make space sustainable. And now it's actually voluntary for us to make sure that at the end of life of the satellite, we have to bring the satellites down. There are a few ways of doing this. The first, easiest way is actually for us to steer the satellite such that the largest surface area faces the traveling direction of the satellite. This increases the drag surface area, and because the drag increases, the speed will eventually slow down and we will come back to Earth and burn off in the atmosphere. So that's how we manage it.
Wonder what kind of data rate are we talking about, and to the subscriber, what kind of package can they look forward to?
Okay. We are still in the middle of developing this space IoT protocol, and we are going to work with AddValue to develop this space IoT protocol. So the protocol will actually determine what's our data rate, and of course this will be based on what the customer needs. But IoT data itself is actually a small packet size, so it's low data rate we are talking about, which is why it's not quite a big engineering challenge. The challenge here is how can we receive so many devices at one go? It's not about the data rate. Yeah.
Any other questions? I got one for you, Zhening.
Okay.
Have you find any early stage customers that is interesting in this technology or your commercial solutions?
Yeah, in fact, we have been talking to a few companies. I'll give you an example. One of such company is actually ChipSafer. They're actually based in Brazil. And what they do is they do livestock monitoring. So the cows, they actually design a tag to be worn on the cows. And this tag provides data such as the position, the location of the cows, the health condition of the cows. What they're facing now is because in the farmlands, there's no connectivity at all. So this solution is actually something for them. Yeah. So this is one of the example customers that we have.
Yeah, thank you for the presentation. I have one question regarding competition.
Yeah.
You mentioned that now the nano satellite competitors are mainly focusing in Europe and Australia.
Yes.
Okay, so that means there is some benchmark or reference that you can take. How successful are they? Are these kind of, these competitors, and actually how many of them? Who are they?
Okay, I can discuss with you more on who are they when you come by our booth. But at this moment, the nanosatellite industry that's serving IoT, it's still at I'll call it as a pickup phase. So the companies are also trying to get satellites up there to start offering the service. So it's a matter of the time to market. And we believe that because we are partnering with more, we believe that the partnership with people who are experts in these areas will give us an advantage to the time, for the time to market. Yeah, but please do drop by our booth. I'd like to take the conversation further. Yeah.
All right, we have time for the last questions. All right, if there's no further questions, I believe Zhening will be very happy to take any question later on. He might come out, and he has a prototype at the booth. So do drop by and have a chat with him. Thanks, Zhening.
Thank you.